Hi guys, I am logged on here just a little bit early to our classroom, Geology 106, Introduction to Earth Science. We will be starting in 10 minutes at 4:30 officially, but I've got the live stream up and going so that people want to drop in a little bit early to the live stream and whatnot. So yeah, we will officially start though at 4:30, so in 10 minutes. All right. So I'm going to keep going on and getting ready before we officially kick off the live lecture for class today. All right, so let's go ahead then and make a sign here in the background as people tune in, just to let you guys know that we aren't starting early. Don't worry, I'm not starting without you guys. All right, hopefully I can set this up, prop this up somewhere where people can see that maybe. All right. I think that's probably gonna work. All right. So it looks like we've got one person here. Maybe that's just me. I guess we will find out though soon. So it looks like we might have one or two people already tuned in. If you are tuned in already, go ahead and comment down below your name if you feel comfortable doing that. Also, perhaps let's see maybe what you're thinking about doing as your major, or if you've already declared a major. There should be a chat box on the side or down below where you can type in messages and whatnot. So for me, I actually majored in geology. And originally I wasn't going to major in geology because I didn't actually think I was smart enough to do it at first. But another faculty at Everett Community College convinced me to just give it a shot. So yeah, so I actually stuck with my intended major. Not super awesome. All right, we have some Aveline. Did I say that right? Aveline, I hope so. Going for accounting currently. Switched from computer science. That's awesome. My husband actually did the same thing. He started out as computer science and then went into majoring into accounting. And now he actually works in computer science instead of accounting. So, but anybody else here, intended majors or majors that you're thinking about doing or going into? So yeah, I see that we have a couple more people. Go ahead and chat or comment in the chat box off to the side or off to below, maybe your intended major, your name if you feel comfortable doing that. And also lets me know that the live stream is working so far and that people are able to hear everything okay, and audio's coming through and whatnot. I'm also curious too if there's a lag between when chat comments are submitted and then also when they are actually come through on the live feed on my end and when I get to see them pop up. So we have, is it Michaela? I don't know if I'm saying, I'm not the best at pronouncing names. Normally in actual like live classrooms, like in a real classroom setting, I have students go around and say their names so that I don't butcher your guys' names trying to like say them because that's just not fun and it's awkward for like everyone involved. If I go around and just butcher everyone's name, Michaela. Okay, awesome. Good. I got that right. And you're an Earth System Science major. That's awesome. So what kinds of, do you have any specific avenues of employment that you're looking at going into with Earth systems, environmental related stuff perhaps, or something like that? Let's see, looks like we're also sitting at about 7 people right now. So I'll probably give it just a few more minutes before we fully get started here. So for those of you who have joined in the last few minutes, we're not starting yet until 4:30 officially, and I'll probably give it another minute or so before we completely finish, officially start. I've got some chats coming in through here. We have Echo, who is an AAS DTA, direct transfer, general transfer. Don't try pronouncing your last name. Okay. Not the best. I'm not the best at pronouncing names. I try, but you know, doesn't always translate through. We also have Genesis logging in, who's a communication studies. Awesome. Very cool. Anybody else who's logged in already or signed in already, intended majors or majors that you're thinking about going into? Yeah, I think there may be indeed some sort of a small lag between when people type in comments and then when it finally like shows up over here on my end. Not entirely sure, but so hope you all have been staying sane so far during social distancing and quarantine and whatnot. I've been trying to do, in addition to work, a bunch of things like here and there to try and stay busy, try and stay sane during social distancing, one of which being watching Tiger King recently. My husband suggested that I start off our live stream by saying, "Hey, all you cool cats and kittens," but I don't think I have the heart to do it. I think that just mentioning it is about as close as I'm going to get to starting out my live stream that way, but no, I just can't do it. Okay, so we got a few more people in the chat with some intended majors, Abby, hopefully I pronounced that right, running start student and going for an AAS DTA. So I'm not sure what an AAS is. Is that an Associate of Arts and Science, I'm guessing? Yeah, abbreviations. So an Associate of Arts and Science DTAs, I'm guessing what that must mean. We also have Jose in here as well. Awesome. It looks like we've got 9 of our 18 students. So we've got about half of you guys logged in so far, which is great. Aha, echo confirmed. Avi. Okay, Avi. All right, I think I got it now. Hopefully. All right, so 4:31. Hopefully most of you guys have had a chance to check out the Canvas page and poke around on there. I've posted up our syllabus this morning, got that all live for you guys. I figured that today we could go over the syllabus and kind of some course expectations, what the class is going to look like online, as well as maybe even start. I'm hoping to start a little bit on the plate tectonics today. Not too much, just a little bit to get our feet wet. And then we'll finish talking about plate tectonics during the live lecture on Wednesday. Let's see, 4:32, and looks like we're still probably have a few students who may join us a little bit late. Let's see, that is also one thing too that I do want to mention to you guys. I do want students to actually be here for the live lectures, tuned in live. That way I can get some feedback from you guys during the live lectures. Also, I'm wanting to be able to do hopefully some sort of conference calling style live Q&A after these live lectures. I'm not sure. I'm still kind of debating between, I'm thinking of using Zoom primarily, but I'm also kind of thinking about doing Google Hangouts as well. So go ahead. Another thing to comment there in the chat box. Comment with your preference, Zoom or Hangouts for doing like live Q&A afterwards, where we can have hopefully some face-to-face, and maybe I can actually like get to interact with you guys virtually and whatnot, beyond just a chat window. However, if you guys still have questions like during the live lecture on YouTube or afterwards, and you don't have a camera to like hop in on Google Hangouts or on Zoom, you can always also ask me questions in the chat window at the end of lecture. So if you guys have access in another window, or perhaps maybe you printed out a copy of the syllabus already, let's go ahead and go over that. So for learning objectives, most of what we're going to be covering in my Geology 106 is going to be a lot of geology. We'll talk a little bit about oceans as well. Geology is my strong suit, so I tend to be really focus really heavy on the geology side of earth science. For our kind of class meetings, we'll be meeting here on YouTube Live and on Mondays and Wednesdays at 3. I'll post a little reminder I'll post a reminder, kind of a scheduled YouTube live session on YouTube, just to kind of, so that you guys know, like, hey, there's a little reminder up there for when this is taking place, but I think you guys will probably get the hang of it if you haven't already. So, and what we'll do during class meetings is we'll have a lecture. I'll probably I have some small whiteboards that I'll be using. I've also been, I've posted some of the PowerPoint slides, but without any of the text on them online. And the reason is so that you guys can either have these up in another window on your computer and type in notes, or if you're kind of like a hard copy type of person like me, you can print out the lecture slides and then take notes directly on them. I pretty much will be sticking though, kind of going through those slides during our live lectures. And then again, hopefully having some sort of Q&A after the live lectures. So what you will also need for this class, you're going to need a copy of our textbook, which I have here. It is Foundations of Earth Science by Letkins and Tarback. We're currently on the 8th edition. Cover should look like this. You're also going to need to purchase a small rock kit if you guys haven't already. The details are in a Canvas announcement online as to the rock kit's name, number, and also where the link to where you can go to buy it. We will be using that in a week from today. So if you haven't ordered it already, make sure you do so ASAP. By the time you add shipping, it comes out to $30 for the rock kit with shipping and handling. So the other thing that you guys are going to need for this class is the ability to watch these live lectures. You're also going to want a reliable internet connection, particularly for when you guys are taking exams. Excuse me, exams are going to be timed, and as such, you're definitely going to want to make sure that your internet's not going to give out on you partway through your exam. Another thing that you're going to need for this class, I didn't include this on the syllabus, but it is probably the most important thing in taking any online class, is patience for reading instructions. How well you do in an online class is going to be directly tied to how carefully and how thoroughly you read instructions, especially in classes where there is no like live lecture or posted lecture or anything, or if lectures are kind of shorter, like I'm hoping that they will be here for this class. So definitely take your time whenever reading instructions and make sure that you thoroughly read those. Course policies. Let's take a look at some course policies. If you are struggling in class, or if you're unsure about the content, you started going over stuff and you're like, I'm still really just struggling with understanding this stuff, or, you know, I'm a little bit shaky here or there and I'm not positive I understand. I've watched some videos, you know, the Earth Revealed videos. Links are in the modules, by the way, for the Earth Revealed videos. And I've read the chapter and, you know, gone through other resources available to us, and I'm still a little bit shaky. Please don't hesitate to email me and ask a question either via email, or we can also set up, again, some sort of live meeting, whether that's through like Zoom or Google Hangouts or something. I'm definitely here for you guys, the students. I think that's probably my favorite part about doing this job, is getting to interact with you guys and getting to help you guys understand and learn more about geology. So don't hesitate to ask if you have any questions or need help with any of the material. Another really important thing is assignments for this class have to be turned in on time. I do not accept late work. So make sure that you are pretty clear on the upcoming due dates for assignments, and that you always submit them before the time. I have the time for assignments set at the due date time set for 3 p.m. on class days. So on Wednesdays, you'll see that we have our focus questions, which is a smaller assignment that we have. It's designed to basically guide your reading and your learning and making sure that you're focusing on some of the really main concepts that we're going through. And those are due on Wednesdays at 3. They are due in the midst of the week of the chapter that we're covering. And the reason for that, again, like I just said, is because it's supposed to be guiding you through the process of going over that particular chapter. And it's kind of also like walking you through the studying process. We also have lab assignments each week. Those are going to be due in a week from the day that we start that particular topic. So this week's topic is plate tectonics, and we are starting today. So the plate tectonics lab will be due in a week from today, which is the 13th. So it'll be due then on 7 days from now, will be the 20th. All right. So that's kind of the rundown of what assignments will look like for this class. Going in a little bit further with the course policies, answers on assignments need to be written in your own words to receive credit. That's both for the focus questions as well as on labs. And the reason I'm definitely okay with people like working with other students in the class. I'm okay with you guys looking at extra resources beyond even our textbook, as well as other resources that I provide to try and help you answer the focus questions or work on the labs. Definitely fine with that. And in a normal classroom setting, I actually typically have my students work in groups in order to complete assignments. However, since we are going to be doing this class online this time, it's still acceptable for you guys to work with each other. But again, I do want those answers to be in your own words, because rephrasing things in your own words, number one, it helps you to retain the information. So the last thing that you guys will want to do is just kind of like, hit up another student in the class and be like, hey, I definitely don't know what to put for this particular question. What did you put down? And then just copy and paste it. Because then when the test comes around, you will be up a creek without a paddle, because you will have like just no idea, and you won't have actually like learned anything. And I tell students this for my in-person classes as well when they're working with partners on their labs. I'm like, the last thing you want to do, the very last thing you want to do is just ask your group mate, like, hey, what did you get for this part of the lab? And then just write it down. You definitely don't want to do that to yourself. Trust me. So answers need to be in your own words in order to receive credit. I have had people turn in assignments where they work together and they just wrote down the same thing. And I, in situations like that, I do give both students 0 points. So make sure that if you are working together with another student, that you guys write everything in your own words. Also, anything that you guys turn in the form of like a photograph or a scanned document and submit that way, please make sure that your handwriting on the photograph or scan is legible. I need to be able to read it in order to give you guys credit. And I definitely am not going to be like in retrospect after you've turned it in being like, hey, what did you put down for this part? I can't read it. You guys definitely need to be making sure before you turn it in that everything on there is readable. Some pro tips for taking good photographs of your assignments is if you're able to get some daylight. The days are a bit longer now, hooray. So we do have some more daylight hours. I really recommend finding a spot by a window with a good light source and taking a photograph of your papers kind of by near a window. A terrible way to take a photograph of your assignment is in a room with like no windows and no natural light and just like one overhead light. And then you like go like this and lean over your paper and block out the one light source. And then there's just this giant shadow of like your of your head and shoulders completely obscuring like the writing and whatnot on your assignment. So make sure that you are taking good legible photos of any assignments that you turn in photograph copies of. All right, so also cheating in this class includes things like plagiarism of copyrighted material, as well as just general cheating of putting down other people's answers, right? Having someone else like take your tests for you, things like that are definitely not acceptable in this class and receive 0 credit. Both are also can result in a failing grade as well as further action by the college. So please be mindful of not doing anything like plagiarizing or cheating. And if you have further questions about what constitutes plagiarism or cheating, please go ahead and let me know. Ask me if you have any questions about that. Also, there are no makeup exams. My exams are offered during a specific time window of the day. And that will be, I still haven't yet decided exactly what the time windows are going to be on those exams. So to be determined, but I will definitely let you guys know. However, that timing window is probably going to be about an hour or so, and you will need to be online during that specific time on that day to take the exam within that time window, right? And it's going to also be a timed exam, so you'll only have so much time to work on it. So you really need to make sure again that you have that reliable internet connection and ability to take the test during that time. I'm also contemplating that what we might do for that is have on test days, like the first half of when we would normally meet, which would be a Monday or a Wednesday at 3, be designated for taking the test. Excuse me. Designated for taking the test. And then the rest of the time after that doing lecture. Excuse me. I'll be right back. My throat's dried up, so one moment. All right. Much better. So, I don't give makeup exams, so make sure that you are there during that time. I also don't give extra credit assignments. There may be extra credit offered sprinkled throughout the quarter. That's not too unusual for me to do. However, I do not give like an extra credit assignment if someone is not doing super well in the class and they're like, man, I really could just use a little bit of a buffer on my grade. I do not provide those extra credit assignments to buffer people's grades. So what that means is that now is the time to start doing well on your assignments. because what you guys do now is going to impact your grades. So speaking of grades, moving on, the next section of the syllabus is grading. So I have online as in Canvas, as well as there's also a link in Canvas on the syllabus tab to a downloadable version of this Google Doc where you can see the grading scale. There are 4 items that are graded in this class. Items, 4 categories, I should say, of graded work in this class. The first category is labs, and labs are worth 35% of your grade. The next category of graded assignments in this class are those focus questions that I mentioned, and those are worth 5% of your grade. We will have 2 midterms, and those 2 midterms are worth 40% of your grade, so 20% each of those midterms. And then the final is also worth 20% of your grade. So then the next table on the syllabus just indicates what percentage at the end of the quarter, when you have like a like 90.235% on Canvas, and you're like, okay, so where exactly does that set me, in terms of, did I get an A-, did I get an A, etc. That's the breakdown for that. Maybe I can even come in here a little bit closer and you guys can see that. Special needs and accommodations. If any of you guys have special needs or accommodations that you've been to the Center for Disability Services and you've received accommodations through them, please go ahead and email me and let me know as soon as possible so that we can get talking about that. And we can make sure that we're getting your needs met 100% and completely. I'm also trying to be really understanding about that sort of thing. I myself also have a learning disability as well. And so I totally understand going through school with various challenges that are completely out of your control. So don't hesitate to contact me about that. And if you're like, hey, I have a learning disability, but I've never heard of the Center for Disability Services at Everett Community College, you can also email me and I will get you guys set up with chatting with them about seeing if there's any accommodations that would be helpful for you. There's also some frequently asked questions tacked on to the end of my syllabus. Those are kind of like the questions that people, I know that when I was a student, I was always wondering in the back of my head, but I was like afraid to ask my instructor. So I just have some of those tacked on at the end of the syllabus there. Reasonable accommodations for faith and conscience. This is a new section that you'll see supposed to be seeing on all of your classes syllabi. This year, I believe it's actually a statewide thing that now students get 2 excused absences per year that are attributed to faith or conscience. You can read more about that down here in the fine print. If you do need to take one of those 2 days and it overlaps with one of our class days here when we're doing a live lecture, please let me know as early as you can about that with at least 1 week in advance so that way we can work out some accommodations and such for you. Oh, someone said they have a fossil collection. That's so awesome. I love fossils. In case you guys can't guess, my learning disability is attention deficit disorder. Yeah. So, all right. So that pretty much does it for talking about the syllabus. Before I move on, Does anyone have any questions about stuff that maybe I didn't mention in going over the syllabus, stuff about what is class meetings going to look like, or grades, expectations, etc.? Oh, someone else has a fossil collection. That's awesome. So I'll give you guys a minute to maybe type. I actually didn't start my fossil collection until after I started actually pursuing my major in geology, just because I wasn't super interested in fossils necessarily. I definitely had a rock collection though, that's for sure. Let's see. No, I don't. I have. Let's see. So Brendan asks if these lectures will be saved as videos so that you guys can rewatch them later. Yes, they will be saved during the quarter. I'll probably take them down though after the quarter is over. But yes, I will be leaving them up so that way you guys can rewatch the lectures, or just in case there's some sort of complication that happens and you're unable to attend lecture. I definitely want to be as accommodating as possible during these like really extreme times that we're living in right now, where, you know, at a moment's notice, there could be some sort of, you know, like family emergency or something very easily, very quickly, very suddenly, and then you won't be able to, like, say, maybe attend the live lectures. So I will be leaving these lectures up. However, I do want you to attend the live lectures and make sure that you're setting aside that time. It's also nice because then for studying, you can go back and rewind and like rewatch the lecture. Man, I wish I had that when I was a student. That would have been phenomenal. But so it's kind of like, hey, we're finally getting the nice things that we always wanted. Ability to rewatch our lectures. What do the labs look like and how do we complete them? Asks Noah. The labs are going to be a little bit different for each week. What I'll be doing is on the assignments page, under the assignments tab, you can see all the assignments that I've posted thus far for our class. You can also find what assignments we're doing and what labs we're doing by going to the modules tab and clicking on that week's module. And the assignments should be in that module. Once you click on the assignment title, it'll take you to a page just dedicated to that assignment. So this week's lab assignment is called Plate Tectonics Lab. So when you click on that title in either under the assignments tab or under the module, it's going to take you to a page that has an item description, and I have some instructions written in there. And then at the bottom, there are links to Google Documents where you can download the file. For some reason, Canvas's assignments feature, when I go to post an assignment, it doesn't let me attach a file. It gives me plenty of fun tools that I can use in creating assignments, except attaching a file. So I'll be posting them that way through a link to a shared Google document where you can download either a PDF form or you can download a Word document file of it. So for completing them, you can either print out the lab assignment and complete it by hand, and then photograph the assignment and turn in photographs or scanned copies of the assignment. Or you can use document editing software to also complete the assignments. So if you want to use, whether that's Google Docs, Microsoft Word, Adobe Acrobat, or etc., or for some of our assignments, you will have to like color portions of a picture. You could even do that like online, or not online, but using some kind of picture editing software as well. I'm fine with whatever path you choose to take, whatever works best for you in completing the assignment, whether that's using software to do it, or whether that's doing it by hand and then photographing it and sending it to me. So when you are also in that same assignment, the description page for the assignment, there should be a button in the top corner. I believe it's the top right corner that says submit assignment. And when you're ready with your files, you click on submit assignment, and then there it should take you to yet another page where you can upload files and then send them to me. Hopefully that answers the question about like how to find the labs and complete them and then submit them. Each lab is going to look very different because it's completely tailored to the type of content that we're going to be covering. So this week's lab is all about calculating the rate at which tectonic plates move. And we're going to be looking at Hawaii in order to try and figure out and calculate that. So details, of course, on that are going to be forthcoming or coming soon in a bit after we do some lecture on plate tectonics. The assignment is posted, so you guys can hop in there and work ahead and whatnot and check that out. So are there any other questions that anyone else has about stuff that perhaps I didn't remember to mention? Another thing too, I'm hoping that lectures only go for about an hour each day. We'll see. That could be foolish optimism on my part though, because I know that I tend to give longer lectures, but we're going to try and keep them hopefully around an hour. So it looks like there aren't any other questions. If you have a question though, go ahead and type it. And we'll circle back around to that. In the module for this week's, I have posted in there a Welcome to Geology 106 PowerPoint. And in there, I can't recall if I took all the text out. I may have taken the text out for those slides and then it's just the pictures, but we'll go ahead and go over that PowerPoint real quick. So for kind of an introduction into my classes, one of the things that I like to do is give you guys some tips for how to read a textbook, a college textbook. I can't recall what class I first had an instructor give me these tips in, but they are, for me anyways, a lifesaver as someone who has a learning disability. And even for people who don't have learning disabilities, honestly, a lot of people say that this is just a more effective way for them to get through reading a textbook. And then it's just far more effective in terms of retaining knowledge as well as helping them comprehend the material. So, alternative way for reading a college textbook. I highly, highly recommend not starting at the front of the chapter and then just reading until the very end of it and just going start to finish. No. Don't do it. I mean, if you're that person and that works for you, I mean, power to you. But a lot of people that doesn't actually work, that doesn't work really well for them. So my recommendations is when you're going through, say, a chapter in the textbook, I always turn to the first page of the chapter And usually there's like an intro page, kind of like this is what the intro page in our textbook looks like. And I recommend reading kind of like the essentially table of contents or introduction. If you turn the page on, like chapter 2 is the one that I just happened to turn to in our book. There's kind of like an introduction paragraph up at the top. And I recommend reading that first. And then instead of going in and straight to the text portion of the textbooks, I recommend next going through the chapter and looking at all of the pictures, the diagrams, and the figures, and kind of skimming those as well as their captions, right? Recommend skimming those first, because then that's going to give you kind of a general idea of what kind of stuff you're going to be looking at. And then don't yet dive into the text yet either. We have more to do before we finally dive into the text. You'll want to turn to, you'll hopefully after going through and skimming all of the figures and stuff, finally reach the end of the chapter. And usually for most textbooks, you will come to a section that is kind of like a summary type of section. Different textbooks are going to give them different names. In our textbook, they call the section Concepts and Review. I definitely recommend reading that next, because that's going to give you kind of a Reader's Digest version of everything that you're going to be going over in the textbook, right? And that's going to kind of warm you up for learning about those concepts. And then finally, after you've read that summary section that comes at the end of most college textbook chapters, then start going through and actually reading all of the dense paragraphs and whatnot that are in the text, the pages like this guy. So that's my suggestion for how to read a textbook. It's also, imagine that it's also how you want to go through and read scientific journals. It's the way that pretty much all of my instructors recommended that you read a scientific paper when you're doing research and whatnot. Is start with the introduction, then go through and skim all of the figures and their captions, read the summary, and then go through and read the entire document, the entire research paper. So I also like to talk about why bother studying geology. So why would we want to study geology? Who cares, right? I mean, I also like geology is not exactly a topic that a ton of people are super familiar with, right? I used to tell people, yeah, so I'm, in college and I'm studying geology, and they go, oh, geography. What do you want to do with geography? And I'm like, they're not the same thing. Geology is different. Geology is better, in my opinion. Sorry to all you geography people out there. It's just not my cup of tea. It's wonderful. But why study geology? What is important about geology? Well, actually, everyone's daily life depends on geology. So some ways that your life actually depends on geology is things like energy resources that power your life. So gasoline in your car, right? Or perhaps like natural gas. Some of you guys might use natural gas in your furnaces to like heat your home, or perhaps you have like a natural gas stovetop. Those are both geology related resources that geologists go out and locate these resources. Also, the raw building materials for most objects that you use in your day-to-day life have rocks and minerals used in them to build to build that product, right? So, for example, computers and cell phones, right? Going into all of the parts and pieces that make those up. We use things like quartz for like silicon wafers and stuff. And we also use like coltan in like resistors and capacitors and things like that. So most people don't realize it, but their day-to-day life does actually depend on geology, as well as things like water resources, like groundwater and etc. Another big reason why we should bother studying geology are things like natural disasters, you know, things like earthquakes, volcanoes, you know. It's definitely worth knowing about that, especially here in the Pacific Northwest in Washington State, where we have both. Yay, woohoo. Hooray for geology hazards, as well as things like landslides. We also have a lot of those out here too. And we're going to be covering all three of those in this class. So also, like, my favorite thing to tell people, like, why study geology? Like, why geology? It's like, well, we also tell you like where you can and can't build things, and like where it's safe to build and where it's unsafe to build. So there are a lot of subdisciplines in geology too. So there's stuff like engineering geology, environmental geology, geophysics and hydrogeology and seismology, volcanology, just to name a few. So, mineral and energy exploration as well. So there are lots of different applications within geology. So that's kind of my brief intro into geology, the wonderful world of geology. Let's see, let's go ahead and transition into talking a little bit about plate tectonics. I still have about 15 minutes that I was planning on doing our live stream. Does anyone have any questions so far? If you do, go ahead and sound off in the chat. Otherwise, if you are able to pull up in another tab the PowerPoint for plate tectonics, that might be a great thing to do, because I'm going to go over just the first few slides in there. If you have something to take notes on, I'd also go ahead and take a quick second to go ahead and grab something to maybe take notes with. A lot of you guys probably weren't expecting to like do some like real rigorous like lecture during the first live stream. That happens also like during my in-person classes, but I like to hit the ground running, you know, just like to dive right into it. So I can just like sense, you know, 16 of you guys there on the other side scrambling, trying to find something to write on, or pull up like the lecture slides. Again, the lecture slides are just the pictures, and there's room to like take notes on those if you guys decide to print those out. So who here has who has heard of the theory of plate tectonics? Who maybe hasn't heard of it? I've definitely had both in my classes before, people who have and have not heard of plate tectonics. Some people in my classes have heard of plate tectonics, but they don't really know what it means exactly. They're like, yeah, I've heard something vaguely. I've got this vague idea about what plate tectonics are, but like don't really know for sure. All right. So Alicia says that she's familiar with the term. Awesome. I saw a great meme online, the one with like the dinosaur like this. And it said on the meme, you know, are tectonic plates dishwasher safe? I thought that was great. Hooray for corny geology memes. So not really. I have never heard of it. Okay, awesome. We've got this great wide array of people who have, various experience then with the term plate tectonics. Some of you guys have never heard of it. Some of you guys are familiar with it. So let's go ahead and talk about it. The first thing that we have to chat about, though, before we really dive into plate tectonics, is something that most of you guys are familiar with, which is the structure of the Earth's interior. So I have a whiteboard here showing Earth's interior, right? So most of you guys are probably familiar with this, that we have, our Earth is made up of several components. The surface of the Earth is what's known as the crust. It's a really thin layer of solid rock, right? It's the stuff that we stand on. Then after that really thin layer, this is not to scale, by the way. It's a lot thinner than what I drew. Then the next portion of the Earth is called the mantle. The mantle is really divided, if we want to be honest, in terms of material sciences and how solids behave. The mantle is actually made up into two different sections, and we just call it the upper mantle and the lower mantle for the most part. There are other divisions too, where people break it up into the asthenosphere and the lithosphere. We're not going to really talk too much about that during this live stream, but there are kind of two areas in the mantle, the upper and the lower, and there's kind of a gradient transition in between the two. It's not a super sharp boundary. Then we have the outer core and the inner core of our planet. So the reason why we are a bit more distinct about these two and separating the two out. Historically, we thought there was just, the mantle and the crust, the mantle and the core. And we thought that was all that there was. However, Inga Lehmann, I believe that she was a European of some kind, seismologist, who using math and seismic waves and really complicated stuff, determined that the core is actually divided into two sections. There's a solid portion and a liquid portion. So we have a solid inner core and a liquid outer core. Before we didn't, historically, there was a point in time where we didn't know that. We thought there was just a core beneath the mantle. Turns out, though, that there's actually a liquid portion and a solid portion. So that's why there's a more distinct boundary between those two, as opposed to the mantle, where they kind of like the upper and lower portion kind of have a bit of a gradient in between the two. So we have to know this first in order to kind of understand plate tectonics. Some of you guys may have also had the Earth's crust, mantle, and core described to you guys using the analogy of, say, like an egg. And I actually hard-boiled some eggs this morning here so that I could show you guys this analogy. So here I have a hard-boiled egg, right, where the shell would be representative of the Earth's crust, the stuff that we stand on. The white of the egg would be the mantle, and then the yellow yolk would be the Earth's core. However, we now know that our core is, made up of an outer and an inner core. So it's not a perfect analogy because we only have just a single core here with this analogy, but the rest of the analogy is actually really good, and it's also phenomenal for teaching plate tectonics. So the idea of plate tectonics is that the crust aka the shell of the egg that I have here, is not just is actually broken. So I have another hard-boiled egg here. I will crack this guy here, hopefully. Maybe if I can get, I probably need a harder surface on which to crack this guy. So we'll use this lid here. If I roll it down, hopefully you guys could hear the crack. A little bit of whatever, eggshell ASMR, whatever. So now here we can see that I have a hammer. Yeah, no, my rock hammer, I think it's in my car from rock hounding last summer. And I'm just lazy and left it in my car. But here we can now see that I've broken the Earth's crust, if you will, into plates, if you will. So each of these broken sections of the shell are analogous to a tectonic plate. So that is basically the theory of plate tectonics. See if I can pull up one of these pieces. So this would be like a tectonic plate that I'm holding here in my hand. So the Earth's crust is broken up. It's not just a complete, perfect continuous crust around the Earth. It's a broken eggshell. And these plates sit up on top of the Earth's mantle, right? These broken plates. The interesting thing about plate tectonics is we believe that these plates actually move and kind of jostle around a little bit very slowly. And the reason why we believe this is there's various evidences that people have observed over time that the theory of plate tectonics explains really, really well. And let's see, how am I doing on time? We've got a few minutes so that I can start talking about some of those evidences. It explains a lot of observations very well. It explains volcanoes, why we have volcanoes where we do. It explains why earthquakes happen. And it also explains several other very interesting phenomena that we've observed. Let's start by chatting about Alfred Wegener really quickly. So as well as F.B. Taylor. Alfred Wegener is considered to be kind of the father of this theory of plate tectonics. There, of course, as usual, were other people involved, some predecessors who kind of had most of the idea fleshed out before he came along and took credit for it. But we'll kind of just talk mainly about Alfred Wegener and F.B. Taylor. So F.B. Taylor started talking about stuff like tectonic, not exactly tectonic plates. They didn't have the theory completely fleshed out, but they started looking into these curious things. F.B. Taylor around 1910, and Alfred Wegener started looking into this stuff around 1924. So part of this theory of plate tectonics, some of the things that these gentlemen were looking at that started them eventually getting them down this path, getting us as scientists down this path to, Earth having, being a broken eggshell. Some of the observations that they made were stuff like the fact I have a 100% accurate and 2-scale drawing here of all the continents. One of the things that these guys noticed, as well as many other people, was that this coastline here looks an awful lot like the inverse of this coastline here. And that the two could almost fit together like a puzzle piece. Anybody else ever noticed that before? I feel like I kind of noticed it as a kid. And that, it just it always stuck out to me as being strange that this shape was very similar to the shape, this shape over here, right? So that's one thing that they noticed. And they were like, that's weird. That's weird. That can't just be coincidence, right? I mean, that's weird. So that was one of the things that was being looked at. Another thing that Wagner was also noticing, let me get my notes here. And Wagner was also noticing they were tracking fossils as well, the distribution of fossils around the world, right? And they found that there are some fossils of animals, say, that live on this continent, that also live on this continent, as well as like over here and over here, you know. And it's just kind of odd that these animals, supposedly, you know, before mankind was around to be building boats and transporting animals from continents to continents, it's like, this is kind of weird that we have, you know, the same fossils, land animals on different land masses that are not connected to each other. That's just kind of strange. Same thing with like plants. And not only that, but the story gets even weirder. So if you guys happen to have the PowerPoint pulled up, you can kind of look on the second slide here at this bottom picture. Do you guys see the orange patches? Orange colored land masses on there? I would draw it on here, but I'm going to butcher it. So I'll kind of try a little bit here. So we've got like, you know, stuff here, as well as, you know, here, a little bit there, a lot of Greenland, a little bit of like Scandinavia up there. I'm terrible at geography. Pretty sure that's Scandinavia. I don't know. Even more curious, scientists discovered that the same rocks are found on different continents. And when I say the same rock, I don't mean like, oh, hey, it's granite here and granite over there and, you know, granite over there as well. It's like, no, it's the same granite. Like chemically, the chemical composition of the granite is the same. These came from the same like source and were created at the same time by the same geologic event. But they're on opposite sides of the ocean. That's weird. That is weird, right? So people like Wagner and F.B. Taylor started getting this idea that perhaps these continents were once actually together and weren't separated by an ocean. And that perhaps the broken up, perhaps the crust, somehow the continents are able to move around the surface of the earth, right? Somehow they didn't, at that point in time though, they didn't have a very good mechanism for how this might occur. The other problem was that, you know, in the 1910s and in the 1920s and the 1930s even, I think it was like end of the 1940s, no one knew what was below the oceans. We had no map of what was below the oceans. It was just a giant blue abyss. No one had any idea. So it was very difficult for them to try to come up with, you know, explaining how they're, you know, these continents could have once been together and now they're separated by an ocean because we didn't even really know what was underneath the oceans to help flesh out this idea. So let's see, looking at time, we're at 5:30 right now. See if there's any other final parting ideas that I want to go on this. I think that we'll probably stop there for today on plate tectonics, and we'll pick up with some more of the evidences, the interesting observations that people were making that have thus led to this idea of plate tectonics and the idea that the crust is broken up into these plates that kind of slowly move around. Sometimes they're bumping into each other. Sometimes they're moving away from each other. Sometimes the edges of the plates are moving side to side against each other, kind of scraping past one another. So we'll talk more about that, and we'll talk more about what happens at the edges of these plates when they collide, when they separate, or when they slide past one another, as well as what geologic features form as a result of the plates moving and whatnot. So the focus questions are also going to be due in a couple days, Wednesday at 3. So spoiler alert, you guys will actually end up having to read ahead and find out the answers to a lot of the stuff that I was just talking about. But we'll talk more about it as a class altogether. And also be sure to watch those Earth Revealed videos. I've linked in the modules these Annenberg Media videos. And they're actually really, really great videos that were made in the 1980s, I think. The computers look really funny in these videos. And so does the fashion and the hair. It's great. It's great. You guys will learn to love James Sad. He's a wonderful host. But I definitely recommend watching those Earth Revealed videos sometime during the week. If you want to watch them before the start of Monday lectures, before we begin a new chapter, that's also fine. It's kind of the idea that repetition really helps with learning stuff. And they go over a lot of the same content that we're covering in class, but they have a different way of presenting the material and it coming at it from a different angle sometimes really helps different learners to absorb the material and kind of get a grasp of what's being covered and whatnot. So I recommend checking out the Earth Revealed video for this chapter, the plate tectonics. Link is in the plate tectonics module. And if not, though, don't worry if you're unable to watch it between now and Wednesday at 3. That's totally fine. But you definitely do want to watch it before moving on to the next module. So yeah, let's see. There's been a lot of chat stuff that's been going on. So the Atlantic Ocean widening up. Noah's on to, you're ahead of the game here. You're ahead of the curve. So I have some prior knowledge. Did I ever read or watch Journey to the Center of the Earth? I haven't. I know, it's a shame. I don't know why I haven't yet, but sometime I'm going to check that out. So, any other final questions that anyone else has before I sign off here on YouTube? Did anyone also want to do a Zoom type of meeting, or or perhaps like a Google Hangouts? You can also pop in the chat and be like, nah, I'm good. Nah, this format works for Alicia. All right, so it doesn't look like we have any questions. I've seen a few chats pop up. Thanks for the live meeting. Yeah, thanks guys for joining. So again, these will be posted and stay up here. So yeah, with that, let's go ahead and conclude. You guys can email me. I'm reachable via email during regular business hours. So that's Monday through Fridays at about usually 9 or 9:30 a.m. till 5 or 5:30 p.m. A little bit later on Mondays and Wednesdays. But I tend not to check my email outside of business hours. But on Mondays and Wednesdays, I'll probably be poking around online until at least 6. So you guys can always reach out to me during those times. I tend not to check emails on the weekends too, but I will probably change that this quarter since we're doing an online class. So, but yeah, with that, I will see you guys on Wednesday. So yeah. All right. Have a great week and stay healthy, and we will see you next time.